Hello everyone, welcome back to ptet.chemistry channel. So my name is Mr. On, and in this tutorial video I will go through this topic 2 for the Chem 5070. This is the syllabus for the people who are taking this particular O-level, or which is equivalent to IGCSE or GCSE chemistry worldwide. It's a pure chemistry course, and this is for the syllabus starting from 2023 onwards, so for the people who are sitting for the exam from 2023 onwards. But to be honest, chemistry, the chemistry for the next couple of years will not change that much anyway, so the lecture tutorial, this lectorial would have been applicable to you preparing for whatever 14 to 16 years old exams that you'll be taking. So in this first section, we're going to go through these elements, compounds, and mixtures. So something that look really simple, but in reality, they can be very confusing if you don't actually know the differences between each and every one of them, as you are expected to be able to. So Cambridge says that, or whatever syllabus that you're doing says that, candidates should be able to describe the differences. So it's not stating, it's not just outlining, but it's describing. So describing means in detail. So you need more than just one line. You need to talk about differences. So this is plural because you need to know more than one difference. That's why it's plural there, between elements, compounds, and mixtures. So to begin with that, we need to think about the definition for each of these: element, compound, and mixture. So from your lower secondary, you will have heard of an element. So an element is basically whatever you found in the periodic table, they're all elements. So what is the definition of an element? So it's a pure substance. Okay, so it's definitely a pure substance. It contains only one type of atom, or some books will say one kind of atom. So essentially they mean the same thing, one kind or one type, but the idea is one. All right, and it only contains one type of atoms, so it's not different, it's not one atom, it's actually one type of atoms. So I better highlight the whole thing. Okay, and therefore it cannot be broken down into simpler substances. All right, so cannot be broken down into simpler substances by chemical method. So you will see that a lot of students really like highlighting stuff, but sometimes research by education experts have shown that just by simply highlighting stuff does not mean the student actually remember what they have highlighted. It's just a satisfaction feeling that you have done something, but without you going back to revisit the definition, to reinforce the memory inside your mind, as well as to apply it in various examples. It's very hard for you to think of definition just because you have highlighted it. It's very hard to remember it. Okay, so you gotta use it, as we will do in the next couple of examples. Yeah, so what is important is elements can exist as atoms or molecules. So example, helium, you see helium in the periodic table, neon, argon. So these are all existing as single atoms. So in reality, so they all exist as helium, neon, and argon, single atom. So only one atom, individual atom. So that is element. But you also get things like nitrogen, oxygen, hydrogen, fluorine, chlorine, etc., and these are N2, O2, H2, F2, Cl2, Br2, I2. So if I show you the periodic table very quickly, so all the noble gases, this is group 8. These are what they use in the periodic table. So these are the Roman numeral. This is Roman numeral for 1, Roman numeral for 2, 3, 4, 5, 6, 7, and 8. V is number 5, so Vi is 5 plus 1. IV is essentially before the thing, so it's before the 5. Okay, so it's actually 4. V and a 2, that is 5 plus 2 is 7. V and a 3 is 5 plus 3 is 8. So these are what we call, they are group 8 elements, and I'll come back to revisit this term, group 8, later on. So all the noble gases exist as individual atoms. Okay, so as individual atoms, so they are elements, but they exist as individual atoms because they only contain one particular type of atoms. For things like fluorine, oxygen, nitrogen, chlorine, bromine, iodine, what else? A couple of other things as well. But among all those things, you will have N2, O2, F2, Cl2, Br2, I2, and I forget H2 as well. Okay, so these are the symbol of the elements. That's why we have used the symbol instead of the name hydrogen. So they all exist as molecule. So what is molecule then? Okay, so molecules are not single atoms. Molecules are made out of more than one atom. So if you have more than one atoms combined together, you have a molecule. All right, so these are molecule, and they are also elements. So the topic, the subtopic was element, compound, and mixture. So these two are elements. Element can exist as single atom. As we wrote earlier, it was just helium, neon, argon, krypton, etc., etc. There is no number 2 at the bottom because they exist as just one single individual one atom. There are two atoms in one molecule. There are two nitrogen atoms in one molecule, but within each molecule is the same atom. Elements contain only one type of atoms. As long as the atoms are the same, you are called an element. It's not a compound because the two hydrogen atoms are the same, the two nitrogen atoms are the same, and so on and so forth. Elements contain only one type or one kind of atoms. They can, however, exist as atoms or molecules. And then each molecule of an element can consist of two or more atoms that are chemically combined. So as I mentioned earlier, N2, O2, H2, etc., etc. The next bit is on compound. So what is a compound? So a compound is also a pure substance. So pure substance because it's only one type of compound, but what is different is there is two or more elements that are chemically combined. Importantly, in a fixed ratio. So what does fixed ratio means? It means that for a compound to be formed, you need however many of element number 1 and however many of element number 2 in a fixed ratio. Yeah, they cannot be atoms, but they can be molecules or ions. All right, so example of molecules. So just now H2 is two hydrogen atom. If I have HCl, these are two different atoms, or you would say two different elements, and they are chemically combined. They are chemically combined in a fixed ratio because there's one hydrogen atom and there's one chlorine atom. So the ratio is 1:1 here according to the formula, and this will make more sense when you come to chemical bonding in the next topic. You will have come across HCl when we did the diffusion question earlier in topic 1. So it's not like the first time you have seen this, yeah? What else can you have? You can have H2O. H2O is also two different kind of elements, hydrogen and oxygen. But here the ratio of hydrogen atom is two hydrogen atom and one oxygen atom. So 2:1 fixed ratio. They also talk about this thing called ions, and I'll deal more with ions at a later stage when we, in fact, in the next subtopic, we will start talking about ions. Okay, so for now, you can just believe me that it's not atoms, it's molecules or ions. What is important also is that the properties of a compound it differ, meaning it's different from its elements. Okay. So earlier, I think I showed a video in lesson that phosphorus is a very reactive element. It can catch on fire if you expose it to air. But then once it reacts with the oxygen in the air, it forms a stable compound because the compound is stable, but the element phosphorus is very reactive in air. So that's what I mean by the property of a compound differ, or it's different from the original properties of the element itself. Yeah. Next bit, you have a mixture. A mixture has two or more substances that are mixed together. For obvious reason, two or more substances that are mixed together, and this thing is what we call impure substance. Okay, a mixture is always impure, whether you have a mixture of elements, but because you are a mixture of elements, you become impure. And impure substances melt and boil over a range of temperature. We talked about this in the previous topic under states of matter, where we said that, you know, for a pure substance, whether you're solid, liquid or gas, you will have a fixed melting and boiling point. But for a impure substance like a mixture, you would have a variable. You will have variable melting and boiling point, meaning you do not have a fixed melting and boiling point, meaning you melt and boil over a range of temperature. So we can say pure substances have fixed melting point and boiling point. Of course, when you write them out, you have to write them out in full. I'm doing a tutorial video, so I can do this and I can say this to you. You need to write them out in full in words: melting point and boiling point. One melting point value is different from another boiling point value, yeah? So you can have a mixture of elements, you can have a mixture of compounds, or you can have mixture of elements and compound. There will still be mixture. What is important is the ratio of these substances is not fixed. So questions can also ask you, describe the differences between compound and mixture. So this is one difference: compound containing two or more elements chemically combined together in a fixed ratio, whereas a mixture have two or more substances mixed together in a non-fixed ratio, or in a ratio that is not fixed. All right. So this thing cannot consist of elements, because the elements are already chemically bonded together, whereas a mixture itself can be elements. All right, so the elements are not chemically bonded, unlike in compound, they're just mixed together, so they haven't undergone chemical combination or chemical reaction. Okay, so what is also important is you can separate through physical method. So I haven't talked about it here, but perhaps you can add it. Okay, you need chemical method to separate into its elements. So again, compounds are made out of two or more elements chemically combined together. If you want to get back the elements from compound, you need chemical method to separate them. Okay, so going back to the syllabus, differences, because you need to state more than one difference. Questions can ask you in a table format for all three of them, or questions can ask you just in terms of element versus compound, element versus mixtures, or compounds versus mixtures. That's why there are additional bit to the most basic combinations. All right, so the most basic combination is probably worth 1 or 2 marks on its own, but the rest of the details are some of the things you can describe further or elaborate further for your explanations. Okay, so describing means in detail, yeah. So going through the next bit, which is to do with classifying each of the pictures by placing the correct label in the blanks below. So each of these you will have this one and this one. They are different atoms. So there's to represent the atoms. These are very simple diagrams to represent each individual atom. All right. So looking at these, we can see that there's one black and two white, and all of the molecules. Okay, these are molecules. Remember earlier we talked about the term molecules. Molecules have atoms combined together, and therefore they will give you molecules. So when atoms, these are individual atoms, they are not combining with each other, so these are not molecule, these are atoms. All right, so this is not molecule but atoms. But the thing is also that you have different atoms, because here this is one kind and this is another kind, so they are different atoms and they are not bonded together. So what you have is you have a mixture of elements. In fact, I don't need to write them down, in fact, because all the options are given here. So this thing here will be C, okay, because this is a mixture of elements, because each of these atoms will represent individual elements, and there are two different kind of elements, but they are not chemically combined together, they are just mixed up together. So this is a mixture and not a compound. This is a molecule, but it's also a compound because it's made out of two or more different elements chemically bonded together. One black, two white. Alright, so this black one can be like oxygen, and then you can have a white one which is two hydrogen, which is the same as H2O. So OH2, H2O, two hydrogen, one oxygen, two white, one black. Alright, so it's a compound, but it's also a molecule. So this is a molecule, it's H2O molecule, but it's also a compound, and it's not a mixture of compounds because all of them is one black, two white. All of them is one black, two white. So it's a pure substance. This one is pure because all of them are the same substance. This one is impure. So I can write impure. And this one is pure. Perhaps I can go through all of them and think about pure and impure first, because when something is impure, it's a mixture automatically. A mixture is always impure. Whereas whenever you are elements, whenever you are compound, you must be pure because only one kind of element, only one kind of atoms. When you have only one kind of compound, it's a pure substance as well. Alright. So here I can see that there are two different kind of things. There is one thing and two things. There are two different kind of substances here. So this is impure. This is also impure. Okay, so there are different substances there. Here there's only one kind of substance and they are not bonded together. So this one is pure. This one is also pure because all of them you can see is two white and four black, like that. They're all the same substance. Alright, going back to the other one. So this is pure because all of them are the two white chemically bonded together. The next one, you have these individual atoms, but you also have this one black and two white. That means this is impure again. It's a mixture for sure. This one and this one, this is impure because they are different. This is also impure. So one black, two white, one black, two white. And then you also have this thing. And what else? Again, this is impure. Basically, this is not the same as this. It must be impure. Alright, impure would mean mixture, and we will come back to what kind of mixture is it. Is it a mixture of elements? Is it a mixture of compounds? Is it a mixture of elements and compounds? These are the kind of things they can ask you to label in paper 2, where you also need to explain by using the ideas of what is the definition of element, compound and mixture. Or they can ask you simply in multiple choice which one is the correct choice based on what you know about elements, compound and mixture, based on their differences. Let me just quickly go through the rest of them. So here you only have one kind of substance, so this is pure. So you could very quickly see the rest of them is two black in the between and four white outside. This is two black and one white, and this is different from this. I hope you can see they're different. They try to play a trick on your eye. You always need to read and decide carefully. Two black, one white. Two white, one black. Alright, so this is impure. It is not pure. When I see it's impure, definitely it tells me they are not the same compound. Therefore, it must be a mixture of compounds there. This thing is 4 black on the outside. This is 4 white on the outside. So this is impure again. The next thing is also impure. Okay, so there are only, actually there's 3. No, there's 4. There's 4 different kind of substances there. So black on the outside, black, white on the outside, and then these 3 atoms combined together. 2 black and 1 white, 1 black and 2 white. For the final one, this is impure again. Alright, so when we talk about pure and impure, I go back to this idea of pure substances can be elements or compound, but whenever you have impure substance, it tells you it's a mixture. Is it a mixture of elements, mixture of compound, or mixture of elements and compound? We need to read the question, correct label. Alright, so I've done it for this first one and second one. Based on the definition of a compound, 2 or more elements chemically combined together, and there only one type of compound here, so it's just compound. Here is a mixture. It's a mixture of elements because each of the black one, it exists as individual atoms. Each of the white one exists as individual atoms. So you have a mixture of elements here, because elements can be atoms or molecules. Here, this is an element, this is an element. You have a mixture of elements, so this is option C here. This is a molecule, okay, so it's a molecule, but in terms of is it an element or compound or mixture, so we would say that that is definitely an element, because you know it only contains one kind of atoms, because both are the white colored one. And this is a molecule, but it's a compound, because it's not only one type of atoms. A compound contains two or more. Okay, so here there are two different kind of atoms, or two different kind of elements that are chemically combined together. All right, so you have one black and, well, you have the black and the white one. So there's a compound, there's an element. Both of them are considered molecules, but then this topic is about element, compound, or mixture. So you have a mixture of element and compound, which is option E. On to the next one, you have this, which is a compound. It's also a molecule, by the way. This is also a molecule, but it's also a compound. So we have a mixture of compounds, which is option D. Next one is a pure one. It's an element. It exists as atoms, because elements can be atoms or molecules, but it must only contain one kind of atoms. So that one must be A. Each of these is a molecule, okay, but then there are compound, because it has more than one, it has two or more different kind of element chemically bonded together. That's the definition of compound. Yeah, so this kind of question can also be asked in the theory paper as well. You need to know definitions of which definitions which make up the reason itself. Yeah, so these are element, because it only contain one kind of atoms, but they are actually molecule. So remember, molecule is not the category that we talk about here. Molecule consists of two or more atoms combined together. All right, but a compound consists of two or more elements chemically combined together. So that's the difference. Yeah, element contain only one kind of atoms. So this is not a mixture, because it's pure. So it's an element, because element can be atoms or elements can be molecules. Elements can be atoms or elements can be molecules. These are elements, of course, that exist as individual atoms. This one is a compound. So what you have is a mixture of element and compound, which is E. Okay, this is individual atom, okay, as atoms. This one is a element, but it exists as a molecule, so it contains two or more atoms. Two or more atoms means it's a molecule, but it contains the same kind of atoms, so only one kind of atoms in the molecule, so it's an element. So again, this is a mixture of elements. Mixture of elements would be C. Okay, so it's very it's trying to test the extent of your understanding. It's very easy to make mistakes out of all the confusing options you have here, unless you know what you're doing. Yeah? So this is an element. It exists as a molecule. This is not an element. This is a compound. Compound can also exist as a molecule. Alright, so this is a mixture of compound and element, which is option E, I think. Yep, mixture of elements and compounds, option E. This is a compound, so it should be option B. Okay, so only one kind of compound there. All of them are the same compound. These are confusing. These are two different compound. So if you are careless, you will make the mistakes in a multiple choice question, for example, because here there's two black and one white, one black and two white. So what is this? This is a mixture of compounds. This is option D. This is going to be option D. The next bit, these again are two different compounds. In fact, you also can call them two different molecules, but elements, compound, and mixture, that's the category given in this particular subtopic. Yeah. So each of these is four different compounds. So again, it's a mixture of compounds, and this is two different compounds. So this is again a mixture of compounds. When you see that it's impure, you know it's a mixture. Impure substances must be a mixture, but it's a question of, is it a mixture of elements, mixture of compounds, or mixture of elements and compounds? Okay, so this is it for this tutorial video, where we have talked about the definition of elements, compound, and mixtures, as well as additional characteristics and features that distinguishes or differentiate between elements, compound, and mixtures in terms of what are their make-up constituents, whether they're existing as atoms or molecules or ions, or here can be a mixture of elements, a mixture of compounds, or a mixture of elements and compounds. And in a compound, you have a fixed ratio of the two or more elements combined together, whereas this ratio of the substances that are mixed together, they can be variable. They can be variable proportion, variable ratio. That means the ratio in which they are mixed is not fixed at all. Compound can only be separated into the constituent elements. For example, H2O, the constituent elements means hydrogen and oxygen. So to get back hydrogen H2, to get back oxygen O2 from water, you need chemical method, whereas physical method is much easier, and you can separate a mixture by using physical method, but not compound, which require chemical method to separate out. These have all been covered in your lower secondary understanding of elements, compound, and mixture as well. So that is it from me in this tutorial video, and we have just covered this particular learning objective from the syllabus, and I'll see you in the next tutorial, in the next lecture tutorial video, where I will continue on this atomic structure and periodic table in one go, hopefully, all of this. Alright, so thank you for watching, and don't forget to subscribe to the ptet.chemistry channel and share the channel with friends.